All right. Looks like we are live. Great. If you can hear me in the chat, if you can do me a huge favor, put a plus in the chat if you can hear me. That would be amazing. Just so I'm not talking to myself or just in my own imaginary world doing math on your screen. If you could hear me, if you could put a plus in the chat, that would be amazing. Is my mic working? Am I here on your screen? Hi, Chloe. Welcome back. Wow, I see we have a returning student. Great. Love the enthusiasm. 2 pluses from Chloe. Awesome. All right. Well, loud and clear. Thank you, Raymond. If you are returning like Chloe, if you could put an R in the chat for me, that would be great. But if you're new, put an N in the chat, just so we know who's here at the party with us tonight. An R for returning if you've been to any of my free live lessons thus far before, like Chloe. And if you're new, put an N in the chat just to get yourself acquainted with how to use the chat tonight. You will be participating quite a bit, so this could be kind of your initiation into our chat today. N in the chat if you're new, or if you're returning. Thank you, Chloe. I see you. You might have to subscribe to my channel in order to chat. Just a heads up. And hopefully that works for you. Thank you for modding tonight, Raymond. Love having you here. Okay, well, you're in the right place if you're here for grade 6 through 8 math. This is our free lesson on multiplying and dividing fractions. Super excited to share with you what I have planned today. If you have not opened up the workbook today yet, every lesson in my course will come with a professionally designed workbook. You can find that in the link in the video description under this video, under this screen, wherever you're on. You can find the workbook there and you can follow along. I'm a huge believer in not having to copy down the original question from the board. I feel like that's a huge waste of time. Even when I was in the classroom, I would always create graphic organizers like these workbooks. So have this workbook next to you on your iPad or print it out, whatever floats your boat. But that workbook is there for you today. All right. Well, before I introduce myself, if you feel like any of your friends or family members might benefit from tonight's lesson, copy that link in the at the top of your browser or click on that share icon and share this link with your friends, family members, be a supportive friend, chat in your group chats, whatever you may have. Invite them over to tonight's lesson and we can all have fun together. All right. A little bit about me. I'm Eddie Kang, senior math teacher at my EdSpace. I've been teaching for 9 years in high schools and colleges. I've also private tutored every level from grade 6 math all the way up to students preparing for graduate school. I've taught over 2,000 students in my career thus far, and I hope to be teaching thousands more through my EdSpace. I did really well in school growing up. I got A's in all my classes, got a perfect score on the SAT, and eventually got into my dream school, UCLA. I graduated from UCLA with a pure mathematics degree and started teaching right away. I quickly found I have a huge passion for teaching. I love teaching math. And it's been working out well because a lot of my students, or most of my students, have gotten into the top universities in the nation. They've gotten perfect scores on their SAT math. They've exceeded the standard on every national standard test, whatever you name it. But most importantly, they had fun doing it. And that's what I'm here to show you today, that math can be fun, approachable, and accessible to make you the next generation of math geniuses. So let's get into it. I love starting my lessons with vibe checks. So in the chat, which one of these types of 4 chocolates is your favorite type of chocolate? Image A looks like kind of like a Hershey's bar, some type of bar that we can break up into little pieces. Image B, it looks like M&Ms. Image C looks like a wafer inside the chocolate, like a Kit Kat. And image D, something like a Twix with maybe some type of jelly or peanut butter. Chloe says, I like Kit Kat. Awesome. C with an exclamation point. Love the enthusiasm, Chloe. Yeah, but which one of these would be your favorite type of chocolate? A, B, C, or D? In the chat, let me know. All of these, as you can see, can be split up into different pieces, like a whole split up into tinier pieces, kind of talking about fractions today. So that's how this is relevant to today's lesson. And I love starting my lessons with these vibe checks because it gets our brains running again. For some of you, it might be 8 p.m. in the East Coast. But for those of you in the West Coast, you might just be coming back from some type of extracurricular activity or anything like that. So this is to get our brains activated again and to get our gears running, essentially. Michelle, A, great. Wow, we have that. I think that might be my first answer choice, A, doing these free live lessons for grade 6 through 8 math. That's awesome. I love Hershey's bars as well. If you asked me this question even 10 years ago, I would have gone with image B because I used to love those mini M&Ms in the plastic containers. Used to love those. But nowadays, I would have to agree with Chloe. I do love a Kit Kat bar. It's, in my opinion, the best type of chocolate with wafers in them. So I would have to go with C here. But yeah, all of these are great. That's why I put them on here. I also love starting off my lessons with something called an APK. These are accessing prior knowledge so that you're able to access later parts of the lesson when these come up, and I don't have to do a little side lesson later. I can just take you back to our APK and be like, remember how we did this earlier, and so we can keep the flow of the lesson going. So today's APK is on mixed numbers and improper fractions. An improper fraction is one where the numerator is greater than the denominator. So for example, if I had a pie or a cake and I decided to split it up into 3 separate pieces, I know that's never happens. A cake is split up into multiple pieces, especially if you're having it at a birthday party. But let's say, for the sake of this example, we're splitting it up into 3 different pieces. If I just wanted one of these 3 pieces, I would say I just want 1/3 of the entire cake. Now, if I wanted 2 of those pieces, that'd be 2/3. And if I wanted the entire cake or pie, that'd be 3/3. Now, what if someone said, I want 4/3 of that cake? Now, that would be considered improper. That's why we call it an improper fraction, where the numerator is greater than the denominator. So in the chat, give me an example of an improper fraction. Give me an example of an improper fraction where the numerator is greater than the denominator. If you're not familiar with this lingo, numerator means the number on the top of the fraction, and denominator stands for the number at the bottom of the fraction. Chloe says 6/4. Beautiful. 6, the numerator is greater than 4 in the denominator, so this would be what we call an improper fraction. Awesome. Any other examples? Or we'll go straight into a mixed number. All right. A mixed number has a whole number attached to a fraction where the numerator is smaller than the denominator now. You could also call it a proper fraction. We almost never call it that, but just because we called the other one an improper fraction, maybe we can call this one a proper fraction. So 4/3, how would we write this as a mixed number? Well, 3, again, reminder that a fraction is basically division, right? So if we divide 4 into 3, we know that 3 goes into 4 fully 1 time. So we'll have a 1 out in front, leaving just 1/3 remaining. So we have 1 and 1/3. That is a mixed number. Similarly, with 6/4, I can rewrite this. 4 goes into 6 fully 1 time, and we're left with 2 out of 4 whole pieces. So we have 1 and 2/4 here. So these are what we call mixed numbers. All right. Let's take a look at these diagrams and try to write each of these diagrams as an improper fraction and a mixed number. So part A, write each situation as a mixed number and improper fraction. Look at this first one, the darker shade of blue. How would you write this as a mixed number? How would you write this first one as a mixed number. Mixed number. I see we have one full circle, two full circles, and then the next circle is missing one piece out of the 4. Hi, Max. Welcome. So we have 2 3/4. That's correct. Amazing. Now, how would we write this as an improper fraction? How would we write this as an improper fraction? We have 2 3/4. We can count them all up, right? We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure you're counting these correctly, and we have 11/4. Now, straight from here, how can we convert a mixed number to an improper fraction and vice versa? Great, Chloe. We know that 2 full 4s would be 2 times 4, and then add the additional 3. And all that will be over 4. Using our order of operations, we can do 2 times 4, which is 8, plus the 3 to get us to that 11 in the numerator. Going backwards, we can do exactly what we did earlier. We can think about how many times does 4 go into 11 fully, and that's twice, leaving just 3 of the 4 full pieces left. All right, let's try this next one. In the chat, how would you write this lighter shade of blue diagram as a mixed number? How would you write this second example as a mixed number? Wow, Max, that was super quick. Love the speed there. We have 1, 2, Chloe, same with you. We have 2, 3 holes, and we have 1, 2, 3, 4, 5 parts of 8 parts within the hole. So we have 3 and 5/8. I almost put 3 again because I said 3. 3 and 5/8. And how would we write this as an improper fraction? Without having to count these all up, I can multiply the 3 and the 8, add the 5, and all this will be over 8. And what would that be? In the chat. An improper fraction that's equivalent to the mixed number 3 and 5/8. Great, Chloe. You beat Max to it this time. We have 29 over 8. Awesome. And I'm sure, Max, you got the same thing. Thank you for encouraging others to type in the chat as well. All right, so we're going to need these mixed numbers and improper fractions later, and that's why we covered it in our APK. Now let's get into today's lesson. Multiplying fractions. Oh, you didn't do it, Max? All good. We'll get a lot of practice tonight. Imagine you have a chocolate bar. Here's said chocolate bar. Let's say this chocolate bar is broken into 2 pieces. So you can see here we broke it into 2 pieces, shown by this red dotted line. And you have one of those pieces. We call that half of the chocolate bar. One of 2 pieces within the whole. Now, pretend you want to share your piece with your best friend. You decide to split the half that you have in half again and give them one of those halves. So you're giving one of these halves to your friend. So you're sharing half of your half. And think about it like this. When you share half of your already half chocolate, you are not giving all of it away, right? Just some of them. When we talk about multiplying fractions, we're talking about sharing a part of something. With our chocolate bar, you first took half. That's the first half. And then from your half, you shared half again. That's the second half. This means you shared half of your half, or 1 out of 4 parts of the whole chocolate. Another way to write half of your half is 1/2 times 1/2, which gives us 1/4, as shown in this diagram. And this is where we find that multiplying fractions is fairly simple. We just multiply across the numerator and across the denominator, right? To multiply fractions, we simply multiply the numerators and denominators. And here's something I'm going to show you that you might not have seen in school, but this is very beneficial for later on in your mathematical journeys, in pre-calculus, calculus, statistics, wherever you are. It's really important to note that we're not just simply multiplying across like this, but what's happening here is we can put everything under one division bar. We can rewrite 3 times 5 as the numerator up here and 7 times 8 in the denominator, just like this. Now, some of you that have seen this before might be asking, oh, you can't see the numbers clearly. Oh, no. Well, I'm rewriting it here a little bit bigger, so hopefully you can see those. I'll take a note of that for the next time I do this lesson. So you have 3 times 5 all over 7 times 8. Now, 3 times 5 is 15. And great, Max, you beat me to it. 7 times 8 is 56. Maybe I'll ask you to do this next one. In the chat, what would you get for this following multiplication of fractions? We have 4 times 7 in the numerator and 9 times 11 in the denominator. Quick, mental math. Know your times tables. Hopefully, everyone learned that in elementary school, but if you haven't, this will be a great opportunity for that as well. 4 times 7 over 9 times 11. What do we get there? Great, Max. Love that you gave Chloe a chance this time. 4 times 7 is 28. 9 times 11 is 99. Awesome. Now, for this next one, we'll do the same thing. We have 2 times 3 over 5 times 8, and we get 6 over 40. Anyone notice something we can do for this one? To completely simplify, we have 6 over 40. In a lot of schools, your teacher may mark this one as incorrect because you haven't fully simplified this fraction. What more can we do with this fraction? 6 over 40. Yes, these are easy so far, Max. These are easy so far. I like to start slow and then ramp it up gradually. You're a chill guy now? Awesome. Max, you're returning as well. Chloe says 3 over 20. How did you get 3 over 20, Chloe? For the people in the chat, for your friends that might not understand how you got to 3 over 20 here. What did we do? From 6 over 40 to 3 over 20, how did we get there? Just divided by 2. Great. And we're allowed to divide by 2. Great, Max. Thank you for helping out as well. We're allowed to divide by 2 because, reminder, whenever we have a fraction, that's just division, right? 6 and 40 have a common factor of 2, so it can be rewritten as 2 times 3 and 2 times 20, and the 2's cancel out. And reminder, as you may have seen on my socials, cancel and eliminate are different words. They have different meanings. The 2's cancel out, meaning they become 1s. 1 times 3 is 3, and 1 times 20 is 20. 3 and 20 are what we call prime because 3 and 20 have no common factors. 3 is prime number itself. 20 is not a prime number itself, but this relationship between the numbers, we call they are prime. All right. Now, as we saw in the last part of the previous example, we could simplify the last fraction further, but we could have addressed this before we had even multiplied the numerator and denominators together. We know that 2 times 3 is the same as 3 times 2. Does anyone know what this property is called? Because a lot of you may have learned this terminology in school already. What is this property called where 2 times 3 is the same as 3 times 2? We can flip or we can switch the places of terms that we're multiplying and it'll give us the same thing. It starts with a C. Factor, kind of. We're on the right track here, but it starts with a C this time. This is called we can play a little bit of hangman too. Associative, Sean. Welcome, Sean. Associative, also really close. Getting warmer for sure. Thank you for being brave. Commutative. Great, Sean. Commutative is correct. This is called the commutative property of multiplication. Multiplication. Now, the commutative property of multiplication is very useful in the idea when we multiply fractions. Great, Sean, look at that. You helped Chloe out there. Let's look at our previous example again. We rewrote this at 2 times 3 over 5 times 8, and we got 6 over 40. We divided both by 2. I'm just doing this again, so don't worry. Not speeding ahead here. I'm just copying down what we had in our previous slide, right? This last letter C. I just copied it back down. But let's find a different way to do this time. We have 2 times 3 over 5 times 8. All right, I'm going to rewrite this once again. But this time, I'm going to rewrite 2 times 3 as 3 times 2. And now, 3 and 5 have nothing in common, but 2 and 8 for sure have a common factor of 2. All good, Max. We have 2 and 8 are both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And now we can multiply across. And we get 3 times 1 is 3, and 5 times 4 is 20. Now, you might be wondering, I don't really like this method. It just seems like we're writing more. But think about it. We're working with smaller numbers this time. And whenever we work with smaller numbers, we're less prone to make a mistake, especially on exams where we're dealing with a lot of problems. When we start working with bigger numbers, the probability that you will make a careless mistake skyrockets. So we always want to work with simplified numbers as much as we can. That's why we're learning it this way. Now, for those of you that already know how to multiply fractions, you already knew this and you don't have to rewrite it as a full fraction, and we'll get to that point eventually. But right now, at this part of the lesson, we're learning that using the commutative property of multiplication, we can rewrite 2 times 3 as 3 times 2 and factor or simplify or cancel out common factors of numbers that have common factors in the numerator and denominator, just like this. Let's look at a couple examples. So we have 5/12 times 8/15 for this first one. I'm going to rewrite it as one big fraction. Oops. 5/8 all over 12 times 15. Now 5 and 12 have nothing in common. 8 and 15 also have nothing in common. So I'm going to use my commutative property of multiplication to rewrite 5 times 8 as 8 times 5, all over 12 times 15. Now in the chat, we see some common factors here, 8 and 12. What can we divide both 8 and 12 by to simplify this fraction? In the chat, 8 and 12. Wow, Sean, you're quick with this. I see you've had a lot of practice with this before. That's awesome. But first, let's go step by step. 8 and 12. What can we divide both 8 and 12 by to cancel those common factors out? And we don't want to skip steps just yet because some of us might be seeing this for the first time. 4. Thank you, Max. So 8 divided by 4 is 2. 12 divided by 4 is 3. 2 and 3 no longer have anything in common, so we can move on. Great, Chloe. 5 and 15 then. What do 5 and 15 have in common? What's a common factor between 5 and 15? What can we divide both numbers by? Both numbers end in a 5, so possibly, great, Chloe and Sean, 5s. 5 divided by 5 is 1. 15 divided by 5 is 3. Now we go 2 times 3. We multiply across. We get 2 over 3 times 3, which is 9. Great, Max. I see you followed along as well. Now, why is this? We can further see why this method is very beneficial. Because if we didn't do it this way, from this step, we would have gotten 8 times 5, which is 40, and 12 times 15, which is 180. And ain't nobody got time for that, right? That's a lot more work than the work that we just did over here. So this is a huge advantage to simplifying first before multiplying the fractions across. And we're going to do this same thing with letter B. We have 12 times 35 all over 21 times 16. This one is a little different than our previous example, and I'm going to start to skip some steps here, right? We're getting comfortable with this. We notice 35 and 16 don't have any common factors, but 12 and 21 sure do. What's a common factor between 12 and 21? In the chat, 12 and 21. What number can we use that goes into both 12 and 21? Great, Chloe, Sean, awesome. 3. 12 divided by 3 is 4, and 21 divided by 3 is 7. Now, 4 and 7 are prime. They no longer have any common factors. However, we notice since we have all the terms in the numerator and all the terms in the denominator are being multiplied, we can switch them up now in our heads. 4 goes into 16. 4 and 16 have a common factor of 4. So 4 divided by 4, I'm actually going to do this one in a different color so then you can see exactly what I'm doing here. 4 divided by 4 is 1, and 16 divided by 4 is 4. And in a different color here, maybe in red, 7 and 35. What are they both divisible by? 7 and 35. This is a quick question in the chat. 7 and 35 are both divisible by, they have a common factor of 7. Great, Chloe. 7 divided by 7 is 1. 35 divided by 7 is 5. Now I'm going to multiply across the green and red numbers. 1 times 5 is 5, and 1 times 4 is 4, giving us 5/4 as our final answer. If we did this without simplifying these numbers first, we would have gotten much, much bigger numbers. We would have had 420 over, let's see, 210, 126, 336. And again, ain't nobody got time for that. Yes, Chloe, great observation. 5/4 is improper. So how can we rewrite this improper fraction as a mixed number? Think back to our APK. How can we rewrite 5/4 as a mixed number? We know that 4 goes into 5 fully once. And we have 1/4 left. Great, Chloe and Sean. 1 and 1/4. Awesome. I think we're getting closer to mastering multiplying fractions here. And I love that you mentioned that it was improper, Chloe. Awesome work. Great. Now, we learned how to multiply fractions. Does division work the same? Now, I can't guarantee, but I would think that most of your teachers in school never taught you this way that I'm about to show you. Does division work the same as multiplication? Most of you may have learned of keep, change, flip. Maybe I've heard of multiply by the reciprocal of whatever we're dividing by. But instead, I'm going to tell you division actually works the same. Division works the same. So I can rewrite this as 8 divided by 4 in the numerator. Oops, let me rewrite that. 8 divided by 4 in the numerator, and 24 divided by 3 in the denominator. Have you all seen it this way before, by any chance? If you have, great to your math teacher. If you haven't, they're teaching by a textbook. But anyway, we can actually divide straight through. 8 divided by 4 is 2, and 24 divided by 3 is 8. So now 2 and 8 have a common factor of 2, and what would our final answer be? In the chat, give me the final answer to this problem. We have 2 divided by 8. 2 and 8 have a common factor of 2. So simplify, we would get equal to, great, Chloe, 1 over 4. Now, the reason, yeah, you just did it yourself, Max, but the reason teachers usually don't teach it this way is because of the wider range of problems when it comes to dividing fractions. Let's take a look at this one. This time, if we rewrote this as 5 divided by 3 and 6 divided by 10, it doesn't work out as well as our first example. So now let me ask you this. If I asked you to divide any number by a 2, what's another way I could have asked you that same question? When we divide by 2, this would be the same as multiplying by what number? Think back to our APK. Think back to our multiplying fractions with the chocolate example. If we're having something, that's the same thing as dividing by 2. So dividing by 2 would be the same as, great, Sean and Chloe, multiplying by 1/2. Now let's look at what the relationship between 2 and 1/2 is. Great, Max. 2, any whole number can be written over a 1. Because 2 means we have 2 wholes, and that whole is a 1, right? Whole with the W, right? Not with an H, or with a WH, not just an H. So if I asked you this, if I'm dividing a number by 5, what am I actually multiplying by? In the chat. If I'm dividing a random number by 5, I can rewrite that as multiplication by multiplying this random number by, great, Chloe, 1/5. Awesome, right? 5 can be rewritten just like the 2 over 1 as 5 over 1. So we can multiply this random number by 1/5. Now let me give you another one. If we're dividing a number by 2/3 then, whoa, right? 2/3. Now we're dealing with a fraction, but don't be scared. We've been working with fractions this whole time. What can I actually multiply this random number by if I'm dividing by 2/3? I can multiply by 3/2. all we're doing is we're flipping the 2/3 to 3/2. Yes, Chloe and Sean, amazing work, right? Math, by definition, is the study of patterns. And this pattern works every single time. And that's where the phrase keep, change, flip came from. We keep the number, we change the operation, and we flip the fraction or number that we're dividing by. So KCF, keep, change, flip. Another way you may have learned this in school is whenever we divide by a number, we can multiply by its reciprocal. Many of you may have learned it like this as well. Well, it's not KFC. I know KFC would have been. I know some teachers that use KFC as well just to make it a little more fun. But I like keeping things from left to right just to not confuse you with the order of things. But yeah, KFC would be funny. Multiply by its reciprocal. Reciprocal means whatever number you have, if you multiply by another number, it gives you 1. So 1/2 and 2/1 are what we call reciprocals. So 3/2 is the reciprocal to 2/3. 1/5 is the reciprocal to 5/1, and 1/2 is the reciprocal to 2/1. So now let's go back to our previous problem. Instead of rewriting it this way now, I can rewrite this as 5/6 times what fraction? What fraction can I multiply 5/6 by? Since right now I'm dividing by 3/10 using KCF, or this phrase, when we divide by number, we can multiply by its reciprocal. I can multiply by, great Sean and Chloe, 10/3. Beautiful work. Now, I'm going to rewrite this all over one division bar. And I notice 10 and 6 have a common factor of 2. The reciprocal of 3/10, exactly, Chloe. So what would our final answer be? Go ahead and work on this and give me the final answer in the chat. 10 and 6. Both are divisible by 2. Yes, Chloe, thank you for helping us out. What would the final answer be here? Wow, Chloe is speedy with it. Let's do this out. For those of you that are still working on it, let me take you through this step by step. 10 and 6 have a common factor of 2. So 10 divided by 2 is 5. 6 divided by 2 is 3. And now I have 5 times 5, which is 25, all over 3 times 3, which is 9. Yawn. Max is like, this is too easy. Yes, Max. If you're in, I'd say 7th or 8th grade math currently, this is pretty new, or this is you've been taught this already. So a lot of this will be just filling the gaps, right? Just like you said, you've never seen it this way before, but later on in later math courses, this will become very beneficial, right? So this is what I'm here for. So that's where my experience comes in really handy, right? I've taught all the way up to basically students preparing for graduate school. So I know where these fundamental, foundational topics will come up later on in your math courses, in your mathematical journey in school. Great, Chloe. I see you wrote it as a mixed number as well. Yes, 9 goes into 25 fully twice, right? 9 times 2 is 18. And so we have 2. And how much is left between 25 and 18? Just 7, like Chloe told us. 7/9. Great. All good. Max has just done this before, so we're all good. All right. Let's practice this. Okay, let's practice this. Try this first one. 4/5 divided by 2/7. So in other words, I can rewrite this as 4/5 times what fraction? I'm dividing by 2/7. So in other words, using KCF or our understanding that when we divide by a fraction, we can multiply by its reciprocal. I can multiply by 7/2. I see we're twins now in the chat. Awesome. And when we multiply across, I'm going to start skipping some steps here. 4 and 2. Great, Sean. I see you've already done this problem. Let's see if you're correct. 4 and 2 have a common factor of 2. So now I have 4 divided by 2 is 2, and 2 divided by 2 is 1. 2 times 7 is 14, and 5 times 1 is 5. How would you write this as a mixed number? Great, I see Chloe's there as well. How would you write this as a mixed number? Great, Chloe's mental math skills are through the roof. Amazing. 5 goes into 14 fully twice. And we're left with just 4 on top, because 2 times 5 is 10. And we have 4 more until we get to 14, but 4 doesn't quite fit 5 fully. So we have a fraction where the numerator is less than the denominator. That's what we call a mixed number. If we wrote this as 1 and 9/5, this would not be a proper way of writing this mixed number, because a mixed number is defined by a whole number with a fraction where the numerator is smaller than the denominator. All right, now for letter B. We have some mixed numbers this time. Haven't worked with those yet, so we want to rewrite them as improper fractions first. That's why we discussed this in our APK today. So 2 and 1/3, how can we rewrite that as an improper fraction? 2 and 1/3, how can we rewrite that in the chat? How would you rewrite that as an improper fraction? We know we have 2 whole 3s, so that would be 2 times 3, which is 6, and then an added 1. Great, Chloe. Max said yeah as well. Yes, 7/3 is correct. Now we're dividing this by another mixed number, 1 and 2/5. We have 1 full 5 and tack on an additional 2. That gives us 7/5. And using now KCF, great, Sean. Using KCF, or whenever we divide by number, we can multiply by its reciprocal. 1/1, Max. I see where you're getting there. We have 7/3 times 5/7. Great. You flip the 7/5 to a 5/7. And we get 7 and 7 cancel out. And our final answer would be what? All good, Max. I see you caught your mistake and you're going to fix it. Sean, great answer. 5/3 is correct. Can we write this as a mixed number as well in the chat? And I love that you made a mistake there, Max, as well, because whenever you make a mistake, brain research shows, whenever you make a mistake and you fix that mistake, that's when you really learn, right? If you're just doing things and you're getting every problem right, you're wasting your time, right? When you make a mistake and when you fix it, that's when you truly retain the concept and the skill at hand, because you remember the mistake you've made, you fix it, and now it stays with you forever, right? Or for a longer period of time, a much longer period of time. I think it was something like it stays with you like 10 times longer or something like that. So don't be afraid to make mistakes. And that's what this chat is for, right? Just answer. You're not getting graded on this chat. You're not getting graded on these classes. And even with the practice problems that will come with each lesson, I give you detailed video solutions for every single problem I give you for practice so that you can check your work. Nothing will ever be graded. So don't be shy. Don't be scared. Practice participating, right? All I see is your username. So I really commend you, Sean, Chloe, Max today. You guys are doing great. If you're shy and we're only we're already 40 minutes in, by the way. Time flies. You can start to participate now as well. It's not too late, right? Let's try this last one. We have 3 1/4 divided by 2. How can I rewrite 3 1/4 as an improper fraction? As an improper fraction, how can I rewrite 3 1/4? I know I have 3 full 4s. So 3 times 4, or 3 4s, will give us 12. And we tack on a 1. What would that improper fraction be for this mixed number 3 1/4? You participate a lot in class. I can see that, Max. You're participating a lot today as well. I love it. Great, Chloe. 13/4. I just got your answer. Divided by 2. All right, so if we're dividing by 2 using KCF, keep, change, flip, I can change this division sign to a multiplication. Remember, I keep the 13/4 and I multiply by, flip the 2. And reminder that 2 is a whole number. I can flip it into a 1/2. And now I multiply across. I notice that 13 doesn't have any common factors with the 4 and 2 in the denominators. And this 1, it's simplified fully already. So I can just multiply straight across. What would my final answer be for this problem then? I love that we have some top students in the class today. Love that. Adding value to our lessons. Great, Sean. 13/8 or 1 5/8. Wow, Sean, you're a master at this. You already know how to convert all these as well. Or 1 5/5. Nice. Great, Chloe. Awesome work. All right. That's all the practice. Now let's apply this to how we can use multiplying and dividing fractions to some real life situations. Take Lucas, for example. Lucas spends 1 2/3 minutes reading each page of his favorite book. How many pages can he read in 30 minutes? So let's say we know, or Lucas knows, that he takes 1 2/3, or a 1 2/3 of a minute, reading just one page of his favorite book. And let's say we were doing SLR, silent reading, at the beginning of class, of English class or whatever. And the teacher said, you have 30 minutes of reading today. How many pages can Lucas expect to read of his favorite book within those 30 minutes? Let's think about this. Let's lay it out, right? Or you can put your guesses in the chat of what you think we should do here, right? Lucas spends 1 2/3 minutes for one page. All right. So 1 2/3. I'm going to put minutes here and pages here. So after 1 2/3 of a minute, Lucas has read one page. Okay. Let's say another 1 2/3 passes. We have another page. That's 2 pages. Total, if we added these fractions, we would have 3 minutes and 3 1/3 minutes. More than 15 minutes, less than 30 minutes. We add another 1 2/3 of a minute. We're adding another page. And we're going to continue to do this until we get to the 30-minute mark. And what we're curious about is how many pages. Yes, Max, I remember you and Chloe already have tried this last week. So we're going to let Sean try. Great. What is the operation here that we can use to get to this question mark box? I'm adding a bunch of 1 2/3. Ooh, okay, Sean. I like the way you're thinking. We have 5/3 divided by 30. But now let's think about this for a second. If we took 5/3, let's say we talk about some circles again, and we have 1, 2, 3, and then maybe something like this for 5/3, and we're dividing this into 30 separate pieces, would you agree that would give us a very small number? But in this case, we already know the number of pages will be a bit bigger, right? Because we know we have 1 plus 1 plus 1, and we're increasing in size here. So we don't want a very small number. So how about, you're on the right track, Sean, by the way. 5/3 times 30. Okay, that's another way to think about it. If we do 5/3 times 30, that would give us, we could do this right now, by the way. 3 and 30 have a common factor of 3. So this becomes 1. This becomes 10. So we have 5 times 10, which is 50. 1 times 1, which is 1. So we have 50 pages. But let's see if this answer makes sense. It takes Lucas more than a minute, right? It takes Lucas 1 2/3 of a minute to read just one page of his favorite book. And he's given 30 minutes. So if it's taking Lucas more than a minute to read just one page, would it make sense for Lucas to be reading more than 30 pages? That seems a little off as well. So what's another way we can try this problem? So I love that we're trying, right? The hardest step in math is taking that first step. And I respect that so much about you, Sean, that we're thinking about this, but you're also giving everyone an opportunity to think about, does our answer make sense? And that's what we should always be asking ourselves after every problem. Does our answer make sense? Are we answering the question? And that's what we're doing right now actively, right? We're thinking actively. And once we get this question right, you're never going to forget this. 50 pages, now we know does not make sense because it takes Lucas more than a minute to read just one page. And so in 30 minutes, we should have less than 30 pages read. Right? Even 32 might not make a bit sense, right, Max? Because every minute that passes, Lucas hasn't read a full page yet. So what else can we do? We are trying to think about how many times does 1 2/3 fit into 30? How many times do we have to add 1 2/3 together to get to 30 minutes? So we can actually set up an equation for this, right? We can set up an equation where the number of times 1 2/3 goes into 30. I can say 1 2/3 times some value has to equal 30. Great, Chloe. So in other words, if I moved this 1 2/3 to the other side of the equality, it would now become a division. And now I can find out what this random box is. 30 divided by 1 and 2. Oh, oops, I put fifths instead of thirds. But no one caught it, so we're good. 1 2/3. How can I rewrite 1 2/3 as a fraction? Chloe already wrote it for us. I can rewrite this as 5/3. So if we're dividing by 5/3 using KCF, keep, change, flip, I keep the 30, I change the division operation to multiplication, and I flip the 5/3 to get 3/5. Now, 30 can be written over 1, and if I multiply this through, what would our final answer be? What would our final answer be here? 30 times 3/5. I want to simplify first, right? Simplify first before you get to that final answer. Great, Chloe. I see you got there already. Great, Sean. I see you multiplied across right away. That is correct, but we want to simplify it completely. Love that you're sticking with us here. 30 and 5 have a common factor of 5. So 30 divided by 5 is 6, and 5 divided by 5 is 1. We have 16 times 3, which is 18, and 1 times 1 is just 1. So we know we have 18 pages read by Lucas at the speed that he is going. Great. That was our application problem for today. This lesson would be in our very first module when the course starts. And now, let's try this out. Let me go back to, okay. If you enjoyed today's lesson, put a plus in the chat, or if you're still here, put a plus in the chat so I know you're here. And while you do that, call your parents over or an adult. Maybe they're next to you already. That would be great. Thank you for being here. I have something super special to share with you today. Great, Chloe, BB, Raymond. Love the enthusiasm. Awesome. All right. Our lesson may be ending, but your progress doesn't have to. My EddSpace grade 6 through 8 full year course will start on October 6th. That's a little less than a month from now. Each course will include 2 lessons just like you saw today. 2 lessons just like you saw today each week starting on October 6th all the way through the month of May to June 5th. This course, grade 6 through 8 math, will meet on Mondays and Wednesdays, the same time we met today, 5 to 6 p.m. Pacific time. Every lesson will be video recorded, including this one. It's being recorded right now so that if you have any extracurricular activities or something comes up and you missed a lesson, you can always go back to the recording of the lesson. I also try to follow the national curriculum for all my math courses. But in the case that your teacher uses a different curriculum, let's say they are going to be teaching this way later in the school year, you can always come back to the recording of this lesson and reinforce your skills, get some extra practice before or after you learn it in school again for exam prep. Every lesson comes with a workbook that you saw in the video description today as well. And every lesson will come with practice exam-style questions that I solve in front of you on the screen through a detailed video solution. So that's a huge perk of my course as well. All my lessons come with practice and with video solutions. Oftentimes, you're kind of given practice and you're left on your own, but I make detailed video solutions on every single practice problem I give you as well. But how much is it? When I used to be a private tutor, guess in the chat, how much per hour do you think I used to charge? When does this course start? October 6th, Max. Hopefully I answered that. Chloe, you've been here before, so you already know. But for those of you that haven't been here before, if you were to guess, how much per hour do you think I used to charge? I mean, Chloe kind of gave it away, but yes, I used to charge a minimum of $100 an hour, all the way up to $200 for those students preparing for graduate school or for really high impact exams. Would go all the way up to that 200 range. And that's the thing about private tutoring. Families have to choose between what works and what they can afford, right? Affordability versus effectiveness. You can never get both in a tutor, and that's why we created My EddSpace. You get all of this 2 times a week, starting on October 6th. So every month you get about 7 to 8 lessons, all of that for $99 a month, which is 8 times cheaper than what I would have been charging as a private tutor. And why stop there? If you would like to just pay our annual package, I'm offering you a 20% additional discount on our annual package because you were here today. But keep in mind, spots are limited for this discount. It's a first come, first served basis. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. And this is because I'm very confident that once you join the course, you're going to love it. You're going to be learning. You're going to be at the top of your class. You're going to be filling all the gaps. You're going to be reinforcing the skills and concepts that you're learning in school or have yet to learn. And you're just going to feel so good in class, participating, helping your friends, and impressing your teacher. And of course, at the end of the day, the most important part, getting high marks, high grades in your class. So if you're interested, text me, code word START, to grab that deal, the 20% off on the annual package. You can text the code word START to this number, 512-900-1283. If you don't want to copy this number down, you can scan the QR code and it'll automatically prompt you to text that code word START to this number, just in case you're scared you don't want to mistype this number. Also, if you're interested and if you enjoyed today's lesson, you can follow me on socials at EddieDoesMath, and you can see more cool math tricks, some SAT math prep, and things that you may have never learned in school on there as well. But I'm excited to see all the code words texted to me after I end this lesson today. I'll have a short time of Q&A for any of you that have any questions about my lessons, my course, anything like that. What is the schedule? Great question, Chloe. We start on October 6th. That is a Monday, a little less than a month from now. We'll be meeting every Monday and Wednesday, 5 to 6 p.m. Pacific time. So that would be 8 to 9 p.m. Eastern time. And keep in mind, all my lessons are recorded. So if you have any event that conflicts with my schedule for this course, then you can always go back and view the recording. And yeah, that's the way it works. Yes, Max, go for it. Yeah, thank you for being here. For those heading out, thank you for being here. Hope you enjoyed the lesson and hope to speak with you soon. Code word START. Yes, thank you, Raymond. Yes, 8 lessons per month. We do not meet on holidays like Thanksgiving, Christmas, New Year's, right? Just federal holidays. But for the most part, you'll get 60 lessons total across a span of 8 months. Yeah, the live lessons are really fun, right, Chloe? It helps you interact. You're not just passively watching, but you actually get to interact and learn in live time. Yeah, and that's what My EddSpace is all about. And that's why I joined My EddSpace. I partnered with them to expand my reach, bring great expert teaching to all of you here. What if I need classes before that? What do you mean by that, Max? What if I need classes before that? So before grade 6 through 8 math, is that what you're asking? I also teach 3 other courses. I teach grade 6 through 8 math, algebra 1, geometry, and algebra 2. Next school year, we're planning on expanding to the elementary grade levels and pre-calculus, AP calculus, AP stats, all that fun stuff. My favorite course, I would have to say, is AP calculus. It is so much fun. And that's why you'll notice, for if you have any older siblings joining on in, you'll notice that the way that I teach will be very, very applicable to when you teach AP calculus as well, or when you learn or are in pre-calculus or calculus. And that's kind of the benefit of joining early. And this is why I love streaming for the grade 6 through 8 math course, because I get to basically teach you from the start, right? From the start, and you can journey with me all the way. And you're just gonna, I already know you're gonna be at the top of your class if you start with me here. Can you help me with help in irrational and rational numbers? Maybe a different time, Max. Today is for grade 6 through 8 math. I do talk about irrational and rational numbers in algebra 2 if you're interested. All right, that's where I'll be ending the stream today. Thank you everyone for your participation. Special shout out to Raymond, Sean, Chloe, Max. Thank you and I think Michelle at the very beginning, and BB as well at the end. Great participation today. I can't wait to speak with you soon. Hopefully I see you in my course, in my texts, and yeah, enjoy the rest of your evening. Thank you everyone. W stream today. Bye-bye.